Ready? So I didn't bring stickers, but I have socks and bottle openers. But you will have to ask a question at the end. But not like, what did you eat for breakfast or nothing like that, right? A real question. I know you guys. So, my name is Pierre, and funny enough, I always wanted to give this talk because, so who writes code here? Okay, good. Or scripts. Okay. Because this is the first time I'm speaking at a dev conference. I've always spoken before at a security conference, so bear with me. I'm trying to do that more often. And the reason why I always wanted to give this talk, two reasons actually. The first one is in the recent years, I worked in a red team where I would do a lot of penetrating a company or something like that. And I definitely saw a trend. And I was like, it's a shame that it's always the same things that people get wrong and they get hacked because it's always the same thing. And so I wanted to build this talk. So this talk basically answers the question is, as a developer, if I only time for three things to improve my security, what would it be? So that's this talk. The second reason is working in cloud security. There is a big emphasis on the infrastructure side, and you've seen from the other talks. And I started working in application security before cloud computing was invented. Yeah, I'm that old. So for me, it's always like, yeah, I mean, it's great. We have all these tools, all these scanners, but we still have code that we need to secure, right? And that's the second reason why I want to give this talk. So thank you for being here. I'll be quick. I know I'm just the last security guy between you and your lunch. But I'll try to start with the positive reinforcement slide. So Jeff Williams is really a key respected figure in the security industry. And basically he wrote this nice article on dark reading about saying, according to his experience, developers are always want to do the right thing. Sometimes they don't have the time or they don't have the knowledge to do it the right thing for security. And I teach a lot, I coach, I mentor, and I can only agree with him. So again, I already touched on that. Why does what does talk have anything to do with cloud? Well, there is always code, right? And if you look at a standard SaaS deployment, the amount of code is huge. So there is a tiny place where it's your code, but you have all these layers. So there is a lot of code. So that's why I believe it's important. And let's jump to the first theme. And I think Taswar touched on that. It's get rid of all your hard-coded secrets in your source code. So I'll go quick on this because the previous talk I already mentioned it. I just want to add one thing is the middle part here. Hack yourself first, basically, that's what I'm trying to say. I listed here a couple of tools, but Google, there are many more, where to see how many secrets you might have in your code. And like Taswar said, by secrets, I mean, anything that can help an attacker to pivot and gain more access once he has access to the code. So it could be database credentials, secrets key, service account private key for GCP, secret access key for AWS, etc. And we already covered that part pretty well. So I guess most of you are from Canada, so you know Scotiabank. If not, I'm sorry if you're not Canadian. But basically, they got slammed because they had Muppet-grade security. Muppet-grade. That's pretty bad. So that's an article from last week. And what did they do wrong? Well, two things. First of all, they had hard-coded database credentials in the source code, allowing to access the customer data, basically. Second mistake, For some reason, I don't know the details, but they had a GitHub repo that they meant to be private, but somehow it became public. Someone made a mistake, or I don't know. And so in combination of these two problems, these two issues, obviously, someone found on the internet their own data, and he found the credential and tried it. So Muppet grade. So moral of the story. Always be nice to English, British news reporter, because Muppet grade, it's pretty bad. So think of, within your organization, think of the kind of people or the role you will give access to the source code and the production data. Usually it's very different kind of roles, right? Like there is like this support engineer we might need for one day access to that part of production, and we grant her the access, but it's a case-by-case basis, and at least that's how it should be. Unless you're working for a startup, I guess. Anybody working for a startup? So by leaving secrets that allow you to gain access to the production data in your source code, then the difference between these two roles is removed, right? So that's why it's important. Especially when you have contractors in the mix. Oftentimes you see companies, they outsource the code. So they give access to a contractor that might be at a different country. And then suddenly they have access to the code, and that means access to the production if you're not careful. Now my second theme is, who do you trust? So I try to spend more time on this. And meaning, how do you secure the supply chain? Equifax, the poster child, unfortunately, they used the Apache struts component, and they were a little bit late to patch it. And this component had known vulnerability in the wild, allowing remote code execution. And this happened years ago, and they are still working really hard to try to regain the trust. But just because they had this sloppy vulnerability management process, they'll be forever remembered for that, and that's why it's on my slide today. So be careful about that too. And that's not even the worst, I think. Recently, we've seen direct attack on the supply chain, like this thing. I'm picking up on NPM, but Maven or anything, any package management system is really the same, is that we see attack like this where malicious actors, they take a well-known library that is well deployed in many different enterprises and systems, and they do a short-lived code change, either by social engineering the owner of the project or different ways, and then they are able to inject the malicious code in the component that gets deployed everywhere. And in this case, like Bitcoin stealing backdoor, whatever that means. And we see that more and more. So it's hard, right? And Docker Hub. So a study from several years ago found out that if you scan all the images on Docker Hub, 30% of them had serious vulnerabilities in the lower level, the network stack or the libraries. And at Elastic, I have a colleague, Josh Brussers, who wrote on Twitter something I really like, and I'm paraphrasing, but basically he said, with Docker, everybody becomes an OS vendor, right? And that's exactly it. So if you think of the Ubuntu and the Red Hat of the world, they spend a lot, that's their business model. They spend a lot of time managing all these packages and these patches. But if you are an enterprise and you're delivering something as a container image, suddenly you also have this additional task to do. So think about that. Again, basing on my own experience, so I did a lot of code reviews as well. Code reviews of organizations of various size, various maturity level, and I cannot share the data, but really what I did is before the code review, I will run a tool to count the number of lines. before I unpack the dependencies and after. And then I collect some metrics. And honestly, it was between 90 and 95% of the source code in terms of line of code was not written by the organization, but was a dependency brought from outside. And that's only the application layer. Not talking about the database, the OS, the middleware, whatever. Just your application and the libraries. Right? That's 90 to 95% of the code. Am I the only one to find that scary in terms of attack surface? How about now? So keep in mind that. So really, for me, also now I work for an open source company, and when you add a dependency to your project, it's really, there is no guarantee of security. There is no guarantee of anything with open source. But if you read an open source license, that's the first line. You own your own, okay? You decide to use this at your own risk. The same goes for security. So really think of it, if you need a library, it's up to you to make sure it's secure. And that's hard. It's up to you to, it's like you write, it's the same as writing it, basically. If you bring up a dependency, think of it, it's the same as if I wrote it. I have to take ownership of it, and I have to maintain it. So what can you do? So I listed 4 things here. The one at the top is if the project you're interested in bringing as a dependency is hosted on GitHub, then what I always do is look for GitHub issues, and you filter by label security. That will give you a list of GitHub issues that are labeled as having a security impact. So that's a good thing to do. Second one in the middle is Sonatype as a free version, a limited version of their offering. It's called OSS Index. And it gives you enough information for free. You know, for instance, if you look at the URL, I search for struts, and that will give you the high-level security posture, if you wish, of this specific library you're looking for. It's pretty good. And then OWASP dependency check and dependency track, really good open source tools. So who knows OWASP? Okay. So Open Web Application Security Project, but they do much more beyond web app security. And basically, dependency check is a tool you run locally to, it scans your, either the binary or your metadata or your manifest files, and try to identify all your libraries, all your third-party components, and run that against a list of known components having vulnerabilities. And dependency track is like the managing aspect of it, to track everything in the entire organization. And then there is, if you have a budget, there is a big space right now for what is called SCA, or Software Composition Analysis. So a lot of vendors in this space. So when choosing for a vendor, they are not all equal. So 2 things. Obviously, you will look for, okay, does it support whatever I need, my ecosystem, my build system, etc. But more, in my mind, the value these vendors bring to your company is really the quality of the data, right? So, for instance, all the other ones before I mentioned, the 3 first solutions I mentioned, they look at open source data, okay? Public knowledge about vulnerable components. Some vendors, they actually have a private database, so they hire security researchers, or they scrape the internet and they build intelligence that they will sell you part of their offering, and that's really the value, I think. So choosing an SCA vendor, have this in mind. If it's only giving you the same thing as a free tool already gives you, maybe not. Okay, my last theme. So we saw who do you trust? Now what do you trust? So I guess you've heard of the zero trust architecture and zero trust networks. So think about the same thing for the application layer. I'm not going to go through all of this, but all these class of vulnerabilities, right? If you look at them, they all share the same root cause, right? And the root cause is the developer over-trusting the user input, right? So user input can be direct user input, or can be an API or another component. So just by building some resilience and some defense against input you don't expect, you will that gives you a lot of leverage. That will give you a lot of added security. So for that, what can you do? It depends. I've listed a few things here. But in my experience, this is the part that developers are the more equipped to deal with. You can replace direct input by indirect input. You can use a framework that does some of the input validation for you. You can use a library like OWASP ESAPI, parameterized SQL queries for SQL injection. If you need interchange data, and you always do, JSON is usually a good secure alternative to many other ones, and replace function called by more secure ones. And I think that's the end of my talk. So remember, no Muppet grade security when it comes to hard-coded secrets. The Pac-Man attack surface, 95% or 90% of your source code is not written by you. And don't overtrust the user input. Now I'm taking questions for SOCs.
I actually just wanted to take issue with the statistic you repeated for the Docker image vulnerabilities.
Yep.
From what I read, their methodology was very flawed.
Okay.
Like
and it's old too.
It's
yeah.
Well, there was one from 7 months ago. I was just
Oh.
rechecking it recently, and like they were basing it based on, let's say, OS vulnerabilities. So if I'm using Debian Stretch
Right.
9, then that means that's an insecure container. But I may not be running any software in that container that uses any of the libraries in question. So
but that's always the case.
I was saying the number is very misleading.
But what you said is really hard to measure, right?
I agree. I'm just saying that there's an element of scare factor to that statistic, and there's a company trying to sell their software based around that. I'm just suggesting it's misleading.
Yeah.
But if you're not running it right now, it doesn't mean that you will not run it in future.
Well,
that's the problem. Like if vulnerability is there, like you might not step on it, but somebody else will step.
Right, but if you're just deploying your Go application that's statically linked and that doesn't, run any of the system.
But it's there. So somebody might deploy not Go application, but like PHP or others. So you never, it's there, it's whole, it's there. Somebody, you lucky enough not to step in, somebody might.
Yeah, but what you said is true not only for Docker, but for when I had this slide about the SCA, the software composition analysis tool. It's the same thing, but at application layer. So they say, oh, this library, you have a library XYZ, which has this known vulnerability. You might use it in a way, and most of the time it is, you use it in a way that you don't call this function which has the vulnerability. Does it count? Is it still a risk or not?
There's also risks to upgrading.
It's true, yeah. But there's another addition to that. There's another dimension is, I hate to say that, especially if I'm recorded, but but there is a security in terms of risk, and there is a security in terms of security perception. So we are an open source company, so it's really easy for our customer to take our stack and scan the hell out of it, right? And then they use, oh look, this vendor, he offers free scanning for open source. Okay, right. So they didn't have to pay for it, but so they send us this report, and it's full of false positive. But how can they trust us, saying, oh no, don't worry, don't look here. This is not a problem because we don't use it in a vulnerable way. So do we spend time and effort to upgrade anyway? And because it's a good hygiene anyway, because let's imagine you spend time upgrading to the next version, and then something else, even bigger risk happen to the same library. You already be one level ahead. Whereas if you wait a long time before upgrading, then it might break the API or whatever. So there is also, it's a complicated cost and benefit challenge. Also, I want to say, so these tools, like SCA tools or any scanners in general, they will tell you, okay, let's imagine you have a choice between library A and library B. And everything equal, they are the same, but you're just looking at the security because you want to use the most secure one, A or B. And using these tools, you find that library A has 5 known vulnerabilities that has been fixed. And library B has 0 vulnerability. Who are you going to choose, A or B? Who votes for A with the 5 known vulnerabilities?
Depends on the vulnerability.
And who votes for B, no vulnerability? Okay, nobody's voting. For me, what it tells me when I say, oh, library A has 5 known vulnerabilities, one, it tells me that at least someone already did security audit on it. Once, at least, right? They've patched it. They look at it. They issue a CVE most of the time, which is like a unique identifier for vulnerability, and it's a pain in the ass. It's a huge process. So they went through the process, meaning they take security at heart. And 4, they learned something, and probably they did some variance analysis, or oh, we got this vulnerability, maybe we have the same kind in a different part of the code, so they are more aware. Whereas library B with a 0 vulnerability, what does it tell you? Nothing. It can either be a super secret mission from Israel or whatever, like they spend 5 years testing it, they pay $1 billion bounty, nobody found anything. They did code review every line of code, they have threat model, the heck all of everything, and they never found anything. Or it can be some girl or guy wrote it at 2 a.m. on a Saturday and nobody ever used it, and both have zero known vulnerabilities. It doesn't mean anything, right? It can be super secure, or it can be nobody looked at it. Any other questions?
You see more and more applications using RASP solutions inside of the application in the market? Or
So you mean like real-time security?
yeah, runtime applications.
Yeah. It's very new.
Yeah.
I mean, it's not new, but it's not really I've never used it personally, but yeah.
It's on our checklist. We still doesn't use it, but we know that it's a solution out there.
Which checklist?
From Imperva.
Oh, okay.
That's the company that because we already use them for our their lab solution.
Mm-hmm. Yes.
We see in practice people doing some proprietary schema on the full stack of the open source, so to make it more their own, like you said.
What do you mean proprietary schema?
So putting codes, lines, stuff that unique to them, so that they know that they're gonna get secure code because they modified it so much from the open source that it's their own.
Yeah.
So it's more difficult for people to
Identify.
hack into them, but it's still a valid code with the open source boundaries, but it's so modified that it's a lot more obfuscation.
Yeah.
So do you see that a lot? Instrumentation, secure instrumentation of the code.
So are you saying people forking an open source repo, and then tools have a hard time identifying it's the same? That's your question?
Evolving so that
yes.
It's become more difficult.
Yes. So some tools, some commercial tools on the SCA space are trying to address this by not using a simple SHA-1 match, but trying to look into the code, look into the files, the file structure, but it's hard. It's hard, and it makes it even more difficult. It's a good point.
Yeah. Putting booby traps and stuff like that.
Oh, you mean the backdoor?
Yeah. No, not backdoor. Booby traps. False functions, false stuff that if they
Canary. Yeah. Well, yeah, no, I'd like to focus on the basics first because we still have a lot of work to do. But yeah, it's a good idea. Yeah.
So you don't see that?
No. Last sock.
My girlfriend's gonna like.
Well, actually, I'm wearing that. So you don't need to be a girl. Well, thank you for your time.